Home play for today is on page 331 only. Yeah. Page 331 only. And of course, getting your final signed. That's, like I said, that's the very first thing that's going in there. Signed, final. All right. Our objective for today, I can divide polynomials. Once again, I can divide polynomials. Now, by now, you should be able to know the definition of polynomials. So turn to your neighbor, let them know the definition, simple definition, without looking at your notes. All right, good. Since they already told you the definition, in your prayer model, lock your toolbar, send me the definition. 20 seconds. Thank you. So by now, we should know that polynomials are what? Monomials, or some are difference of monomials, yeah? Yes, Mr. Q. All right, so before we left to break, we did cover division of polynomials. And before I got started with that, I remember I showed you the different ways of writing it. One way of writing it was 3 divided by 4. Another way of writing it is 3 over 4. And the last way was 3 divided by 4. And I said we're going to focus on the last one, which is what? Long division. You guys remember that? And we did an example on the warm-up, so I'm pretty sure it's refreshing your memory. But today we're not going to focus on long division. Before we left, I did a quick introduction to dividing polynomials using something that we call synthetic division. So copy this one, please. Example 3. It says divide using synthetic division. X cubed plus 7x squared plus 16x plus 12 divided by x plus 2. Bless you. Now, when we covered this one, I just did one example. I didn't get too into it. I just wanted you guys to practice the long division more than this one. However, from this point forward, we do need synthetic division because it's it's a skill that we need for the following unit that we're going to cover. So to get started with synthetic division, I said it looks kind of like when we did matrices. You guys remember matrices? Your favorite? Yeah? So we're not going to be using variables. We're going to be using only coefficients. So writing utensils down, look up to the screen. Pick this up. I'm going to do this one using synthetic division. In order for me to do synthetic division, the very first thing I need to check is that this is in standard form. Second thing is that it's in standard form and that all powers are accounted for. Let's see. What's the power for the first term? 3. For this next term, 2, 1, and 0. Is it in standard form? Yeah, from greatest to least. Does it have all the powers accounted for? Yeah, 3, 2, 1, and 0. If that's true, then I don't need to worry about filling in the spaces for whatever power is not there. So that means at this point now I'm going to do the synthetic division using coefficients. Look up to the screen. What is the coefficient of the first term? 1, and then 7, 16, and 12. I'm going to divide that by this. However, I'm going to write this equal to 0 and solve. This is minus 2 minus 2, so x equals negative 2. So I'm going to divide by negative 2. Are we there? Now check this out. This is another way of getting a quotient and a factor. So here we go. There is nothing here. I bring this one down. Now I get started. Instead of dividing, I'm going to multiply. You're like, wait, aren't we dividing? Yes, but what happens to the quotient and to the divisor? We can multiply those to give us the dividend. So basically, we're going and doing this backwards. So check this out. What is negative 2 times 1? And I'm going to write that over here, negative 2. Next, I'm going to combine these two. So what is 7 and negative 2? 5. And I start again. I do it all over. What is negative 2 times 5? Negative 10. That goes right here. And what do? Combine. So what is 16 minus 10? 6. And I start all over again. What is negative 2 times 6? Negative 12. That goes right there. And I combine. So what is 12 minus 12? 0. That is my remainder. So if I already divided according to the synthetic division, that means that I no longer am at the cube spot. This one's going to be my squared spot. So check this out. This is what? 1x squared plus 5x plus 6. That's my quotient. What was the divisor that I started with? X plus 2. So if I was to multiply this times the original divisor, what would that give me? This right there. This is just another way of doing division. Everybody with me? Okay, copy that, please. This is my quotient. This is my divisor. Some of you are saying, Mr. Hughes, so what if we would have had a remainder? What do we do at the end, everyone? We would put here plus whatever the remainder is. But since we don't have any, we didn't write it. Copy that. Once you're done copying that on your screen, is example 3Q. Copy that one on paper and see if you can. I'm going to give you a head start. We'll do that one together, but see if you can do that one by yourself. All right. Let's see how we do this one. What is the first thing we check for? Standard form. Is it in standard form? Yes. Are all powers accounted for? Let's see. 3, 2, 1, 0. Yes. So now I'm just going to rewrite it by using coefficients. What's my first number? 1, and then 5, and then negative 17, and then negative 21. And we're going to divide that by what number? Positive 3. That is correct. So basically I would write this one, x minus 3 equals to 0, plus 3 plus 3. So that means I need to divide by 3. So I draw my line. Since there's no number on the first term, I bring this down here to get started. So then I start. What is 3 times 1? 3. That goes right there. What do we do all the way after we get those numbers? We're going to combine all the way through. So therefore, 5 plus 3, that's 8. I do it again. What is 3 times 8? 24. Combine these two. What is negative 17 and 24? Positive 7. Again, what is 3 times positive 7? 21. Combine the last one. What is negative 21 and 21? 0. So my quotient would be what? This is no longer x cubed. This is a what? X squared plus 8x plus 7. And what is my divisor? The divisor was x minus 3. So if I was to multiply the quotient times the divisor, should give me what? What I started with. And once again, at the end, what do we do with the remainder, guys? I would just add it right here if we had a remainder. By the way, this is called the remainder theorem because if we had a remainder, we would just write it there. Okay. And once again, what is this? It's called synthetic division. Someone understand how come figure out what this? Okay. Let's see if you can do one by yourself. I'm going to leave that up there. I'm going to follow your screen. Example 3 super cube should be on your screen. Then lock your toolbar. As soon as you're done, send that in. I'll give you some time. Ready, go. All right, do me a favor, check with your neighbor, see what they got for example 3 super cube. See if they have something similar to yours. That's you. Okay, here goes the process one more time. Is it in standard form? Yes. Are all powers accounted for? Let's see. 3, 2, 1, 0. Yes. So then I write, what is the coefficient here? 1, 8, 17, 10. And I'm going to divide by negative 5. Does everybody know where I got that from? Yeah, you put that equal to 0, it's all for x. Okay. So I bring down the 1 and I start. What is negative 1 times 5? Negative 5 goes right here. Combined, that leaves me with 3. Do it again. What is negative 5 times 3? Negative 15. Combined, that leaves me with 2. Do it again. What is negative 5 times 2? Negative 10. And what is negative 10 and 10? That's 0. So my quotient is x squared plus 3x plus 2. If it had a remainder, I would do what? Plus whatever remainder goes here. And this one times the divisor, which is x plus 5. Hands, have you got that? Okay, you got this, yes? Now, this is called the remainder theorem. However, in the home plate, they're going to give you something that looks like this. Look up, please. Instead of writing that, they're going to ask you, given this, but they're going to write it as p of x equals to that. Is this a factor? So what do we do there, Mr. Q? Same thing we just did. Once again, they're going to give you p of x equals this. There it is. Is this a factor? So what do we do with that? Well, we divide it to see if it is a factor. How do we know if it's a factor, Mr. Q? If at the end we have remainder of 0, then yes, it's a factor. So what does that tell you? If it doesn't have remainder 0, is it a factor? No. That's the only difference. When they're asking you to see if it's a factor, that's what we call the factor theorem. The other one was called remainder. This is called the factor theorem when they're asking you to see if it's a factor. All right? Show me what you're talking with your with these. Well, we got this, yeah? All right? Okay. Copy this one. Last one. All right. Question, is it in standard form? Yes. Are all powers accounted for? Let's see, this is third, this is first, this is zero. Which one is missing? Second. So let's rewrite this in synthetic. So what do I write first? 7. What is the coefficient of the next one? 0, because we're missing the what? The second power. So what do we write next? -6, and then at the end, 9, positive 9. And we're going to divide by what, everyone? -5. Bring down the 7. Multiply. That leaves us with -35. What do we do here? Combine. Bring down the what? -35. Do it again. -5 times -35. That is, what is it? 175? 175. Combine, that leaves us with 169. Next, -5 times 169. That leaves us with -845. Combine, and we end up with -836. You're like, we do have a remainder. So what if they did like this? Will this be a factor of this one? No, because we have a remainder. However, how do we write the coefficient? Let's see. 7 what? X squared minus 35x plus 169. Yes? And then plus -836. And of course, that multiplied times x plus 5. And that's the home question. You can combine this. Have a good one, guys. Once again, get your final sign. That's the first thing that's going in tomorrow. The second thing is your home plate, which is on page 331 only. Yeah, tutoring today. Yeah, have a good one, guys. Tutoring today, it's free. If I don't see you guys tomorrow. Bye.